For this example, we're going to find the period, the phase shift, the amplitude, and the vertical shift of each of the following functions. When we're working with these functions of sine and cosine, remember that the general form of these is, for example, for sine, a times sine of omega x minus phi plus b, where each of these pieces is going to indicate the values that we need to report for the period, phase shift, amplitude, and vertical shift. However, when working with each of these, it is highly recommended to first factor out the effects of the period change from the inside of each trig function. If you do that, then you will isolate the effects of the period change and the phase shift. What I mean by that is, in the case of a sine of omega x minus phi plus b, I'm going to take the inside expression within sine, and I'm going to factor out the value of omega. That will leave me with x from the first term, and if I factor omega out of the second term, I will have phi divided by omega. This will give me a, which corresponds to my amplitude, b, which corresponds to my vertical shift, omega, which corresponds to my period change, and phi over omega, which corresponds to my phase shift or horizontal shift. There are a couple other things we're going to keep in mind with this, but we'll get to those as we see them. For the first case, for f of x equals 2 sine of 3x minus pi minus 1. First thing I'm going to do to this equation is I'm going to factor out the 3 on the inside of that function, leaving me with x minus pi divided by 3 is pi over 3. This now lets me identify the specific pieces that I need. For example, the vertical shift and the phase shift are pretty direct. In this case, the vertical shift I have is a minus 1, so I will say my vertical shift is 1 down. My phase shift I have as pi over 3, and this means that my phase shift is pi over 3 to the right. My amplitude is the number that is multiplying the function, which is the 2 in front of sine, and my amplitude is simply just 2. Lastly, my period. My period is not just the value of 3 that I factored out of the inside expression. That is the period change. The period is what you get when you take the original period and you divide by the period change. So I will take the original period of sine, which is 2 pi, and I will divide by 3. That will give me my new period, which is 2 pi over 3. Next, for g of x equals 2 minus 3 cosine of x over 2 plus pi over 4. Sine and cosine are going to be very similar in this concept. In terms of identifying the pieces, this is the same as what we were working with sine and cosine. Even the period, because both sine and cosine have the same period of 2 pi. However, yet again for this, what I'm going to do first is I'm going to factor out the number multiplying x. That'll give me 2 minus 3 cosine. The number multiplying x is technically a 1/2. Leaving me with x plus pi over 2 remaining. From there, we should be able to identify each piece that I need. The shifts are just going to be how much you move left and right. The vertical shift here is going to be 2 up this time. If that's a little bit harder to see, remember that we can rewrite the original function so that the 2 constant is written afterward. The phase shift is the value that is adding or subtracting x. Because we're adding to it, that actually means we're going to do pi halves to the left this time. And then the amplitude, again, is the number that is multiplying sine or cosine. In this case, the -3. However, I'm not going to report the amplitude as -3. I'm going to report the amplitude always as a positive number. This is going to be in contrast to how we will use it when we actually graph the functions. We will want to keep in mind that it is a negative value. When reporting the amplitude, though, we will always report it as a positive. So I'll take the absolute value and say the amplitude is just 3. Lastly, with the period, we're going to take that value that we factored out, and just like the previous one, divide that from 2 pi, which means that we are going to get from this 2 pi divided by 1/2, which is 4 pi. For the last case, we have negative sine of pi halves minus pi times x plus 2. When I work with this one, I'll have negative sine, and if I factor out the value multiplying x, which is a negative pi, I will have remaining x as well as a minus 1/2. This brings out one other change that we're going to adjust for this. We are always going to report the period as a positive value, and therefore it is always suggested when you have cases like this, if you have your period change is a negative number, apply concepts of even and odd functions. Cosine would be an even function, and even functions mean that when you have a negative input inside of that function, that is the same as just the function with a positive input instead. Odd functions, on the other hand, mean that when you have a negative input inside that function, you can write that as negative of that function with a positive input. Essentially, that means that if you have a negative for an odd function, you can pull that out. Whereas if you have a negative for an even function, you simply remove it. In this case, sine, as established earlier, is an odd function, which means I can take that negative on the inside and pull it out, and that is going to now give me positive sine of pi times x minus 1/2 plus 2. This is advised not only when reporting these aspects of each of these functions, but also when graphing them, to also use this concept of even and odd functions, as it typically will make your life a little bit easier. In this case, my vertical shift is a plus 2, so that means I'm going 2 up. My phase shift is the value that is subtracting x, the 1/2. And that means I'm going to go 1/2 to the right. This is just like the first problem. The amplitude, I don't have a number in front of sine. However, just like any variable, if you don't see a number in front of it as a coefficient, that means the coefficient is 1. So my amplitude here is just 1. Basically the original amplitude. And lastly, the period. The period, I'm going to take the value that we have isolated away from x and divide that away from 2 pi. If I divide pi away from 2 pi, I will simply get 2.